you everyone for joining us today for our topic of 3D CEI and design. As most of you know, technology in our field is improving quickly, and the way projects are designed and delivered is evolving at an incredibly rapid pace. As our industry has begun shifting from 2D plan sets to 3D models, and really, as with any change, there can be growing pains, but at the end of the day, the advancement of project delivery and really the potential time and cost savings associated with that is critical to our industry. So we think it's a good time to have the discussion on our topic today and work together as owners, designers, inspectors, and contractors to really help move our industry forward. So again, thanks for being here today. So a quick agenda for our meeting today. First of all, we're going to cover the 3D CEI program with the Florida Department of Transportation. Second, we're going to give you a field demonstration by video of some of the 3D CEI rover equipment being used in the field. Third, we're going to talk about preparing our industry for 3D deliverables. Next, we're going to look at contract models and their role in the construction phase of the projects. And we're going to close this out with a Q&A session at the end. So please ask any questions using the Q&A option at the bottom. All right, so I'm joined by a very talented group of speakers today, including our friends from the Florida Department of Transportation and some subject matter experts within RS&H. First of all, we've got Olivia Townsend. Olivia is the construction final estimates engineer at the Florida Department of Transportation. With 10 years of experience at the department, she has previously worked in the state construction, roadway design, and program management offices. Olivia holds a master's degree in civil engineering from Florida State University. Next, we've got Taylor Carlquist. Taylor began his career in the private sector and joined the Florida Department of Transportation in 2015 as a quality assurance specialist. He holds a BS in civil engineering from Florida State University and has over 12 years of construction experience. Currently, as a final estimate specialist, Taylor develops and updates policies, procedures, specifications, forms, and training materials for final estimates and quality control. Next, we have Andrew Posich with RS&H. Andrew has been at RS&H since 2014, and he serves as the design integration lead for infrastructure after spending many years in the highway design group. He brings an in-depth understanding of transportation design and overall three-dimensional workflows related to core engineering principles and interdisciplinary collaboration. And last, but certainly not least, we have Marshall Bailey with RS&H. Marshall is a CEI project manager that manages construction inspection and quality assurance teams. Marshall has extensive knowledge in design build projects, and his expertise is in heavy concrete projects, tunnel construction, commissioning, and operation. So welcome to all of our speakers today. So we're going to start our webinar with the Florida Department of Transportation, and we're going to give you an overview of their 3D CEI program. So to do that, I'm going to turn it over to Taylor Carlquist and let him give you that overview. So take it away, Taylor.
All right, thanks, Justin. So for those of you who don't know, this all started for us back in April of 2022. We were tasked by the director of construction or our director at that time, he's now our chief engineer, to identify available inspection technology tools that could be used during construction to enhance our measurement and our verification processes. We researched and looked at a lot of different tool options. We looked at rovers and base stations, drones, total stations, LiDAR, 3D cameras, you name it. Also, along with that research and through discussions we had with our contractors, some of our key consultants, and some of our department staff, we determined that GNSS rovers used with either an independent base station or the Florida Permanent Reference Network would provide the most benefits to us right now. So we wanted to get rovers out in the field on our projects to use for layout verification, especially now that a lot of our contractors are using the automated machine guidance or AMG for their earthwork activities. But we could also use the rovers for measurements, field record submission, and it would give us the ability to accurately and efficiently collect as-built data, which is becoming more and more of a growing need in construction and for the downstream users of our data. So once that decision was made to move forward with utilizing rovers, the first thing we did was create an official 3D CEI task team that was made up of a mix of some of our department staff. We made sure to have representation from our CAD office, our design office, and our survey offices, as well as some of our key consultants and contractors. But we started meeting to discuss and determine the best course of action for implementing this technology and to establish some of our initial goals, which were to identify pilot projects throughout the state, to develop some CEI scope language that we could incorporate into those pilot projects, and to establish an implementation timeline. So aside from those initial goals, our main focus for this team will be to meet and discuss what we needed to have in place to successfully implement using rovers and base stations for our verification and measurement purposes. And we also wanted to identify what updates were needed to our current processes and procedures to allow this technology to become part of our standards of operation. So this is looking at our the workflow for our pilot projects. It's not a whole lot different than workflow for any of our projects. The only differences would be, so it would start off still, we would get our design files. They would be put in a collaboration site, our Project Solve SharePoint collaboration site. So that would be available to both our CEI and our contractor. Most of our contractors are already using rovers, so they'll pick their type and vendor, and then we want the CEI to also choose their type and their vendor. The main point there is we want our CEIs to be conducting their inspection and measurements completely independent from what the contractor is using to QC their own work. From there, the next step, handling plan changes. If there are any changes considered major plan change, those will be sent back to the EOR to incorporate those changes in a plan revision. If it's anything minor, like field changes, those can just be documented by the CEI on their as-built as they do now, just with redline revisions and having the appropriate backup documentation. From there, the contractor will use the files they need to build out the project. The CEI will use the files they need for their verification, final measurement of items, as-built markups, and then, down the road, we could eventually use some of that data that's collected during construction to build a more reliable and better asset inventory. Obviously, that would require some changes to our current processes if we added something like that in, but that's what this is all for, is trying new things. As far as our implementation, we decided to lay it out in phases, like take a phased approach, kind of taking baby steps. Phase one, we actually just completed phase one and kind of the first part of phase two. Phase one was just getting GNSS rovers out on our pilot projects to verify layout, earthwork, and really just utilize rovers anywhere you could, provide feedback on how it compared to the traditional tools and methods that were already being used. We started out with like 20 pilot projects from around the state that participated in phase one. All of them had different work mixes. We brought RS&H on board to be the experienced support team that we were going to need for these pilot projects. For the staff, they could rely on them for help and for guidance as they learn how to use this new technology. And RS&H also collected feedback and prepared a report for us from all the feedback gathered by these from the pilot teams that we can use to kind of prepare us and help us develop this next phase. The phase 2A is looking at what changes need to be made in our processes and our final estimates documentation to allow for rover outputs and reports to be submitted. Also, kind of a second part to that is to establish some priority construction items that we want to start collecting data on. The second part of phase 2, which is 2B, is is actually piloting that data collection and determining what format we need this data in, or we want to store this data in. And then going on, phases 3 through 5 are probably down the line, but it's all in the direction that we're trying to go. It would lead to a change in our plan revision process for sure, which is something we'll just kind of have to work out as we get there. But we would start with updating the CAD files with the digital as-built data that's been collected. Phase 4 could be updating the actual model. And then lastly, 5 would be attempting to create a digital twin. This is a timeline going back to when we first started making some changes to our construction processes by using surface files. So it goes all the way back to 2018. That's when we sunset our multi-line software that was being used to calculate earthwork using average end area. We've sunset that, even though people still use it. But we recommend that surface-to-surface comparisons be used for calculating your earthwork now. So we support Trimble Business Center. We don't mandate its use. You can use other software that has the capabilities to do surface-to-surface comparison. But that's when we started that in 2018. In December 2021, we had a Quadri pilot project that went through our design and CAD offices. So they were looking at new ways to do things, new ways to have their design review. Then in April 2022, that's when we started our 3D CEI task team. We started doing all of our research. Then there was another pilot project using Synchro that was looking at viewing 3D models and files in construction, which the 3D model viewer is still something that we're looking into, and we hope to get soon. Around that same time is when there was some changes to the CAD requirements, requiring designers to submit earthwork models. So anything designed after July 2022, signed and sealed earthwork models were then required to be submitted. So we're just starting to see those now in construction. So hopefully rovers will help with verifying those models, and a little easier to work with. Fall 2023, that's when we had our kickoff meetings, RS&H and us and all of our pilot projects. That's when that phase began, phase 1. At that same time, we also had another task work order with Kinley Horn to develop an initial 3D CEI training course, which covers everything from basic survey knowledge, rover setup and capabilities, data output, updating models, cutting cross sections, kind of like all across the board, basic knowledge that someone would need to have. It's going to be a part of our construction training and qualification program. So you'll be able to take this course and become qualified to submit rover data for our final estimates purposes, or basis of payment. So that was the idea there. We are working right now until we have all the course material finalized, and we're trying to get that added to our CTQP as quick as we can, which is our training program. So we're working on that. As of right now, the phase 1 feedback, we just received the final report from RS&H on the feedback from the pilot projects. So we'll use that to develop our next steps, which will be identifying what elements of construction we want to prioritize for the rover data collection for phase 2. And then looking even more forward, the second part of phase 2 will be to actually start those pilot projects on data collection. Phase 3 will be to determine what the digital as-builts may look like for FDOT. More discussions will need to take place between our construction office and our other downstream users of construction data to determine what features we want to focus on. Once we reviewed the outcomes of the data collection pilot projects from the 2B, we could then implement the collection of data by the CEIs for certain priority features that we identified. After that, we could look into the next phases, which would be piloting changes to our as-built requirements and then implementing that requirement, where the department would require the CEI to submit more than just a red line marked up PDF as-built. And, looking even more down the road in the future, there's sure to be more iterations and refinement as we learn more about what exactly our needs are and where we want to go.
All right. Thank you,
Okay.
Taylor, so much for that background and information, and great to see FDOT kind of at the forefront of this technology and kind of pushing this forward for the industry. Through our phase one that Taylor had mentioned, we've kind of developed some benefits of advancing this technology and the things that it could help down the line. So those are on your screen. As you review those, just going to ask a few questions here of Olivia and kind of a little more information about where FDOT is going with this program. So Olivia, with FDOT being on the forefront of 3D CEI, why is this initiative so important to the department?
So the department's always looking for new innovative technologies to streamline and develop our standards. And really, we want to reap the benefits of everything that you've listed there on the screen. We want to save lives. We want to save time. We want to be able to increase the data that we have. But this is all part of a larger effort to actually bring those technologies in and have procedures for digital data delivery, verification, and collection throughout all of the different arms of the department and throughout the project lifecycle. In addition to 3D CEI, we've got automated machine guidance policy going on, and we're also, as Taylor mentioned, the procurement of that 3D CEI viewer.
Fantastic. Great information there. How is the 3D CEI program currently being administered at FDOT?
So this is a phased implementation approach, so we can actually learn all the capabilities and use cases for this tool. Phase one was administered through an experienced team, RS&H, that oversaw all the pilot projects as they were learning this technology. They were helping those pilot teams with monthly meetings, helping personnel get trained and learn how to operate the rover. And then also developing and submitting a rover work plan for those pilot teams. And then as we move forward, we're reviewing that phase one report Taylor mentioned to find out all the successes and challenges of that phase one pilot, and then bring them forward into phase two. Really, we're looking at collecting data on elements of construction, particularly final measure in phase two. But we still have some decisions that need to be made as far as how other offices are going to be using this data.
That's great. Yeah, and we've had real good working relationship with our pilot teams out in the field and getting this phase one report pulled together, and look forward to beginning phase two shortly. So with that being said, what's the schedule for the 3D CEI program rollout?
So phase one was recently completed, this just recently here in July. So we're working through reviewing the summary report that RS&H submitted with our upper management, and then developing what we want for phase two. We don't have a hard deadline for phase two, but it would be wonderful, since most of the phase one projects are still in construction, to go ahead and get that ball rolling so they can use their lessons learned in phase two, and we don't have quite as steep of a learning curve.
Fantastic. Well, thank you, Olivia and Taylor, for that background on FDOT's 3D CEI program and where we've come from, where we're at, and where we're going. Really appreciate that information. So next, want to move in and give everyone a 3D CEI field demonstration. So this is going to be through about a 5-minute video narrated by Tony Manos, who's a CEI Senior Project Engineer with RS&H, and Jaheim Torre, who's a CEI Roadway Inspector with RS&H. This video is going to show you the use of some of the rover equipment that you've heard mentioned, out in the field and how our construction teams and CEI teams are using the equipment. So that video should start here momentarily.
All right, so this is our TopCon GPS box. Our brand's TopCons, there are many like it, but this is ours. So initially, whenever you get on site, you're gonna wanna open this up, and it comes with a few pieces. You've got your tablet, which comes with a stylus. If you wanna use that, it's also touchscreen. 2 rover heads, and on the rover heads, they got a couple buttons, but mainly what you gotta worry about is your big old power button. Once you hit the power button, these right here are just indicators, just let you know that you have connectivity. And yeah, let's get it connected. So I'll pick my rover head of choice since we're working off the DOT network. Pick my footer of choice. I'll go with the spike. I'll initially start off by connecting my antenna. Go ahead and it just snaps on just like that. Give it a good twist clockwise and it's tightened. So go ahead. My tablet's ready to connect. So it pops up a few options. You got your rover head. So how do you know it's your rover head? It's got a specific serial number. Where do you find your serial number? Right here on the bottom of your rover head. It's easy just to associate it with the last 3 digits. Once you do that, you'll go ahead, click on your rover head serial number, hit select, hit connect, let it do its loading sort of icon screen. At this point, I'll go ahead and connect my tablet to my GPS device and let it load. This is a GPS rover, which we as a CEI firm use to check the contractor and their work. Currently, we're working off a Department of Transportation network, which in tandem speaks to satellites to give us a specific geoposition. Our contractor themselves are working off of localized base stations, and those base stations sort of give a bit of variance in regard to the checking process. You don't want to be based off the same system because there's no way to check errors and accuracy if you guys are both working off of the same system. So my next step, we just laid out a bunch of curb, I'd say maybe 700 linear feet. When we're given these files from our design office, we upload them into our GPS and rover, and that's how we go about staking lines or checking specific operations on site. So currently, as you can see in the GPS screen, it offers a positioning sort of icon, which is just your regular navigation arrow, which indicates your rover, where it's sitting. It as well has the plans, lines, and et cetera that you can use to stake offsets, to lay out certain areas, et cetera. And as well, you can use this to create surface area nets for whatever sort of final estimate needs you need. So I'm going to go ahead and stake a line, which is currently the lip of curb or edge of pavement. So I'll go ahead, let me restart, click the line I want. And sometimes when you're in such a wide view, it'll give you an option between specific lines that you may have possibly clicked on. So currently, I want to go to pavement, asphalt, or edge of pavement. Click check, hold down, and I want to stake the line. Staking the line will give you the ability to check it in comparison to the plan. So currently the contractor is laying out the physical curb. We have the plan position curb. Once we stake it, we can go to the curb and observe how accurate the contractor is with their layout. So using this, I'm able to, of course, clean off your spike, stake the lip of curb. Using this, it'll be able to tell me a specific offset.
This is an example of tying in the GPS with AMG, which is automated machine guidance. You can see the 2 rovers and the midsection of the excavator. And so the operator knows exactly where he's at with alignment and grade as he's digging the ditch. Normally, I'm going to say this, in the olden days, you'd have stakes in here telling him how far he had to dig down. And right now, you don't see any stakes around here because it's all done mechanically or all done automatically with the AMG. So this machine is talking to a base station, and the base station is talking to the satellites.
All right, so hope you enjoyed the video. Wanted to kind of give everyone a feel of how the models are being sent into the field, and then how that information is being captured and used to actually build the projects in the field. So I hope you enjoyed that. Next, we're going to move into the next section of preparing industry for 3D deliverables. I'm going to turn over to Andrew for the next section here. Andrew, take it away.
Awesome. Thanks, Justin. So this whole entire initiative is part of a larger shift in industry. And that really all starts with the base data that we start off with in the design process. So really, we're looking to shift the way we think about projects from a 2D first mentality to a 3D first workflow. And this is consistent across all different disciplines, all different folks in industry, really just to making sure that we're able to really elevate the way we do plan delivery. So in order to get good data in the field, it all starts with good data early on in the design process. So a little bit more about the evolution in this. We're all familiar with plan PDF sheets and how we navigate that traditionally as part of the official plan delivery process. You've seen those plan and PDFs be digitized. Not a lot of us are printing PDFs anymore for wet signatures. But what we're looking for and really is this middle transition area where we're looking to extract data that we can use today with automated machine guidance and automated inspection workflows that can really see benefit down the workflow pipeline. That involves surface models, 3D component models that can be used, and really focusing on that here today, while still looking forward and realizing this isn't all we can do with data. As you saw in kind of the push for 3D CEI, we're starting with real practical application of this data, while keeping in mind some of the more downstream workflow uses, such as models of legal document, as well as 4D and 5D deliverables, which is incorporating the cost and schedule into your model. Which really is just, again, enhancing the data that we work with and making it more applicable to the design process. So a little bit of information on that, of what that looks like and shift to workflow. Whenever you traditionally start a project or start a job, you've got several things that happen. We have kickoff meetings, we send email correspondence. There's a lot of word of mouth communication that all happen behind the scenes. A lot of effort goes into getting a project started, and in a 2D workflow, that's just as important as any other environment. However, something with the 2D workflow that's, we've all grown to rely on is relying on the latest PDF set of plans. Now, this can be a slight delay in conversations if you're waiting to get something printed to sheets, waiting for someone to place a text label in the PDF or in the plan set. And ultimately, it can get a little confusing. I know there's several out in industry that are used to looking at these for years and years, and they may be second nature. But if you're coming in from a different state or working in a different region, it may take you a little bit of time to get acclimated to a potentially very confusing set of plans. Furthermore, you're relying on these file updates. So for no stranger to maybe a conflict file or clash detection in 2D, you're looking at this file, you have all your disciplines referenced in together, and you're able to build an overlay and really understand how different disciplines work together. So again, making use of technologies and tools within a 2D environment to give you that feedback, all kind of handled in this complex container file. Now that changes a little bit when you shift to 3D workflows. So you still have your kickoff meetings, you still have your email, you still have word of mouth. Basically, these traditional channels are never going to go away. They're always going to be critical to the project development process. However, that latest PDF print that maybe you were waiting for your younger staff, that's not been replaced with the BIM data. So being able to access this information in real time, live, whether you're pulling profile elevations, component quantities, what have you, really helps improve the way you can access the information that is underlying to the design. Your file updates that would traditionally take place in that 2D container file are now happening in a true 3D environment. So being able to see clashes as they occur, being able to work and collaborate with multiple disciplines in order to enhance the way we do project delivery. I'm no longer looking through a subfolder in a different discipline, looking for a spreadsheet that contains an elevation. I'm able to reference that directly from these 3D federated models, which really is what we're trying to ship and push down into the construction workflow to save time and money on the field side. But why are we shifting to 3D? I think we saw great examples earlier of how it can improve the construction workflow process, but a little history of that, of why we're at this stage. I know when I first started off 3D modeling back in 2014, there was a lot of just means to an end. We were just trying to get cross sections out the door as a different tool to get the job done. You see that evolution slowly evolve, though, and you start realizing there's more value, more benefits between the cross sections. So rather than having a model analysis every 100 feet, which is traditional, you're now looking at every 50 feet, 20 feet, 5 feet in some cases. Really, your limited density is really just dependent upon the area or scope of the work you're doing. But now all of a sudden, we're pulling things like quantities. Those are starting to come second nature to you. You're able to jump in and extract volumes very easily. as mentioned earlier, since summer 2022, we've been signing and sealing earthwork models for the state of Florida. A great way to get in there to validate what is oftentimes one of the biggest pay items on the project, and be able to say something that we can share and easily port over to either the contractors for estimating, CEI for inspection, or the owner for asset management. Those earthwork surface can then be merged in with some of the automated machine guidance you just saw previously in the video, whether it's from the contractor side, equipping end graders, loaders, basically making sure that you're able to get your earthwork to grade where it needs to be. But also on the flip side, you're able to show areas to avoid. So if you're really trying to get the full advantage of your models, you're able to actually fence off certain areas, whether it's subsurface utilities or other areas you'd like to stay out of. Ultimately, the goal of being able to look at things from a higher level of efficiency and design, as well as construction, to reduce the errors and emissions, not just in the plans, but also reduce risk overall in the project. With this, we now have a BIM environment that you're able to extract this information. You saw on the automated machine guidance and on the rover itself, how that information that we're putting in from a design perspective can be loaded in the field and identified based on its element classification. So being able to really not just embrace the fact that we have a 3D surface now, but we also have all this additional data that can serve someone down the pipeline of a project. All the way over, and no, haven't talked about that much today, but the goal is to be able to bring this forward to asset maintenance and operation to make sure that these facilities we're constructing now can continue to thrive and benefit as years come. Really cool to see this data come together. Quick example here of what kind of a design federated 3D model looks like. Rendered up a bit, but all that core data is real information, being able to access elevation, clash detection, vertical clearance, so all this additional information you get on the front end is really a powerful tool to be able to help drive home some of those benefits. One of the greatest of which that I actually see, and this is involved as well when you start bringing the CEI involved towards the end of design, is this idea of passive and active QC. Traditional QC on a project happens, set intervals before plan delivery. Sure, there's some that happens along the way, but there's really no alternative for when you're working in that live 3D model of having those conflicts really jump out at you and being able to identify those sooner throughout the construction process. Basically, if something looks right, it's way easier to tell in 3D than in a 2D file, regardless of what discipline you're working on. We're ultimately using this to help broaden our cross-practice knowledge. I know I've been on several projects where there might be a niche discipline involved. That person may not be familiar with transportation infrastructure projects or that familiar state's plan set look and feel. But when you introduce them to that 3D model, they're able to then have the same level of communication and understanding, someone who's internalized the visualization of projects for many, many years in industry. Ultimately, this is just something you can address prior to formal QC. Not replacement of it, but definitely changes the way you look at the design when you start realizing that some of these files are going to be used down in construction. And one recommendation we've seen, there's a few pilots in Florida where we've done this, where we've actually brought the CE on board before final plans. And it's great to get that feedback, get those groups in the models. They can often catch things that may or may not have been overlooked, as well as better prepare your data for use in the actual field. Really, all this just helps build up the team communication. Remember, the model is not a replacement. It's enhancement of that communication. We got a lot of tools out there, so make sure you're using them. Make sure you're taking the time to educate your teams, whether it's the design teams, the asset owners, stakeholders in the process. There's a role that everyone has to play in this greater transition. So make sure that information that they're being shared is matching to their scope of the project. One of my favorite quotes is, the model is only as powerful as its weakest component. So we want to bring everyone up to speed, make sure everyone's speaking the same language and working in the same ecosystem. Now I'm going to switch gears a little bit here and talk about how we've been using some of that 3D design data that I just shared in construction before handing off to Marshall to talk a little bit more about another use case of that. So what we're able to do with these models, you're able to communicate these complex designs a little more easy, a little more fluid. There's a lot of great tools and technologies that enhance the contextual experience you have out in the field. The demo you saw was a simple plan view of the project with elevations that's pulling along brake lines or surfaces. That can really be enhanced. You have some augmented reality solutions that are hitting the market that are very proficient, all with the goal to really help increase the way we're able to validate and confirm the way projects are built in the field. A few other examples that we've actually seen in recent years come up is using the 3D data as a way to enhance current processes. Requests for information, RFIs, seeing official responses where we might have a somewhat complex situation going on that we want to communicate. Being able to use the 3D model itself as part of that communication process to enhance a traditional plan markup is a great way to really get in there and understand the value that the model can bring, and hopefully bring clarity to those out in the field asking those original questions. Whether that's just from a 3D CAD perspective that you can integrate into a 2D plan delivery, which is another great topic for another day, or you're going with a full kind of rendered solution. One of the great other examples we've seen is to enhance the field review process. So prior to a single shovel hitting the ground, we're able to take that 3D model and blend it with reality data of the surrounding environment to kind of walk through the project virtually, basically allowing everyone on the project team, whether it's a stakeholder, contractor, CEI owner, to understand the full scope of the project prior to setting foot in the environment. This comes to light very, very clearly in virtual constructability reviews, which we've gotten a lot of good feedback on, of actually implementing the model data. There's a few different ways this looks like. A quick example here that we're going to share is the use of a few different tools, again, bringing some of the 3D design data forward into a solution that's a little easier to digest for the average person. Taking a very complex 3D model and navigating that model is not always the easiest thing to do. So there's a lot of tools out there that are available for us to bring it into a portable solution that can be shared with anyone. In this case, we're doing before and after comparisons of a potential MSE wall that needs to be adjusted, as well as giving the folks on the team access to be able to walk through and manipulate the environment themselves. Something akin to a high-res kind of Google Earth experience, being able to kind of get an idea of the project beforehand. Again, this look comes in many different fashions, especially with some of the tools in the market. There's a huge push for that augmented reality factor. But I still think there's something pretty clear and clean about jumping in and actually walking you through the project to be able to understand some of the challenges associated with the potential constructability of the work. Another great example, a lot of tools, mentioned Synchro earlier as part of the 4D process. You're able to kind of review the model within the Synchro ecosystem, basically to ensure that that constructability is able to be pushed out there. Some great pilots going on in the state of Florida right now with that, being able to go in there and start tying things like your schedule, like your component cost quantities. Really, 3D CEI is just a baseline for this greater contextual conversation. Really looking just to make the most out of the data that we are able to provide throughout the construction pipeline. With that, I do want to pass it off here to my colleague Marshall out west. He has a great example here of some of the work being done by our CI folks out there that are on some very complex work, tying in the model to the actual field work and inspection. Take it away, Marshall.
Great. Thank you, Andrew. I appreciate it. So today I'll be talking about the $1.2 billion Central 70 project in Denver, Colorado. We actually reached final acceptance in July of 2023. And so this project took roughly 5 years to build, and now we're currently in the second year of the 30-year operations and maintenance period. So for starters, this is how the project looked originally. So the goal was to eliminate a 57-year-old viaduct that was built in the 1950s and lower a portion of the highway. So with lowering a portion of the highway, we also built a 4-acre park, which was adjacent to an elementary school. And then while the entire 12-mile project was being constructed, we had to maintain traffic for the 200,000 vehicles per day, as well as maintain access for the 1,200 businesses that were along the corridor. So as we constructed the lowered section as well as the cover top, we really had 4 major lessons learned. The first one was that a 3D model would be non-negotiable. And we'll get into complexities a little bit later. And then complete and compiled specifications is extremely important that need to be compiled by the designers. So with the cover, we really had 4 major stakeholders as well as 80 companies that were correlated to this work. So making sure that everyone is in lockstep was extremely important. And then also going from the 3D model, but also the mock-ups and proof of concept in the field to make sure all those pieces do indeed tie together and do work together. And then last but not least is making sure that all the operations and maintenance needs are going to be highlighted and obviously correlated to a 3D model, so everyone kind of knows what lane they need to stay in. So first, here's a cross-section of the cover. We did have 3D models that were utilized throughout the construction project, but they were more or less utilized to visualize the phasing of the work. So just an example, especially in this lowered segment, was first initially where the viaduct was originally located, including building the westbound section. So then we took all the traffic from the viaduct and we dropped it essentially in the westbound bore, where we had a bidirectional traffic phase for roughly 2 years. So then during the bidirectional traffic phase, the viaduct was demoed, and then it allowed us to build the eastbound bore. So then right here, this is the final configuration of the lowered segment. So then here, this is just a cross section of the cover. And one of the pieces I did want to emphasize is the jet fan and the clearance envelope of 16.6. So here, I just want to reemphasize just how tight our tolerances truly were for all the surface street tie-ins, including all the cover top elements, and then maintaining that 16.6 envelope where all of those systems would reside, as well as where the final roadway profile would be constructed, because we had groundwater roughly like a foot underneath the pavement section. So here, this was just a snapshot of the 3D modeling that we did use for the cover specifically. Here is a picture on the left of the footprint of essentially just the cover top. And as you can tell from the picture and the image that was provided, is that we really didn't have any additional data outside the actual footprint of the cover. And then the picture on the right is the actual constructed image that we took with drones. But what we really could have utilized, just due to the complexity of the cover top, is having a 3D model that would have extended roughly 50 feet off of the cover approaches to make sure everything as far as utilities was correlated with the cover top, and a lot of drainage features that would be from the on-structure cover, as well as some that went through the surface streets. And then we did have a couple of cover top elements that would have been on and off structure as well. So by just having a more complete model, this would have helped us essentially eliminate a lot of construction issues that we did come across. So we would have been able to highlight these a little bit earlier and making sure that we're working with the appropriate designers and not necessarily working in a silo as much. So here is the cover top. And not just having a 3D model, but also focusing on how important the mock-ups and proof of concept do become. And just reiterating just how tight these tolerances were for some of our drainage elements and the complex shapes that were on the cover top, and making sure that all these parts and pieces actually work together in the field is extremely important. But being able to ensure that the actual model does work, and being able to show that firsthand to our construction folks in the field before any of these elements are actually constructed and start tying together. And by just having a good 3D model, I mean, we would have eliminated a lot of rework and a lot of NCRs in this process. So here, this is a portion of the tunnel systems. So this would actually be an operator screen on our left, but what I wanted to reiterate today is that we do have a presentation online with RS&H's website about the Central 70 lessons learned, which will go more into depth about these tunnel systems and how they were constructed as well as being operated. But for today's case, I really want to focus on tying 3 assets to a 3D model. So as you can tell from the image on the left-hand side, this is what the operator is going to see. So it's very user-friendly and very, very intuitive to show firsthand exactly what's happening within a tunnel at any given point while traffic is traveling through it. But as you can tell on the picture from the right, there's just a lot more going on within the cover than merely just what's on that screen. So just to get an idea, is we have roughly 1,200 lights within the tunnel, as well as 60,000 lineal feet of conduit. and we have 20 fire suppression zones as well as 18 jet fans. So, I mean, that's just a very high level overview of some of the assets that we do have within the cover. But from those assets that would ideally be within a model, there's also the routine maintenance aspect of these of this type of infrastructure. And we have to complete roughly 2,900 routine maintenance inspections every single year. So by number one, having an asset within the model, but also being able to correlate all the construction information that was compiled, as well as all of those routine maintenance inspections to an asset for future history tracking is extremely important for cost. But also if or when there is essentially like a non-routine maintenance issue that does pop up, the team in the field has the best information, and obviously it's really, really accessible. So now kind of just getting into those cost savings, the upfront cost of developing these models is obviously extremely large, and making sure that all of that data and information is making it into these models. But we're essentially living it firsthand with the Central 70 project on how valuable this information becomes. And that one of the major takeaways that we had was that number one, all the information needs to be compiled at the appropriate time within the project lifecycle, and also the information needs to be populated within the model by the appropriate person at that time. So once all that information is populated, and if or when issues do pop up, all the information is there and it's accessible. And then if or when issues do pop up, you're not necessarily having to reinvent the wheel every single time. So you're just saving a bunch of money just by finding the appropriate resolution, but also the man hours it's going to take to deliver a lot of this work. So as far as the manpower that's going to be saved just in construction, but also over the life of the O&M period. So the cost savings would just be endless. So.
All right, Marshall, thank you for that information there, and how this information is used out in the field and on our projects. So thanks, everybody. Thank you for the speakers for your time here. We do have a few questions that have come in that I will ask to our speakers before we wrap this up. First one, I'm going to direct this to Olivia. Olivia, what are the goals and objectives for FDOT in their implementation of this 3D CEI program?
Sure. So really right now, as far as implementation, our goals are really just to encourage the use of the GNSS rovers as a verification and measurement tool. We would like to get pre-construction of verification of existing surfaces, as well as verification of finished grade and hopefully as-built surfaces. And then hopefully be able to actually produce final estimates documentation using the rovers.
Awesome. Thank you very much for that, Olivia. Next question, I'm going to kick this to Andrew, and anybody else who wants to chime in is welcome to. The question is, what are the benefits of the technology? So we've covered a little bit of that in our presentation, but Andrew, if there's anything maybe that hasn't been covered you want to tack on?
Yeah, I always tell people, I think the biggest value is improving the way we communicate, and that means different things to different people. So what I encourage you to do, as you know, we have probably several different people in attendance here, whether you're, from a CEI perspective, you're from the design side, you're the owner in this project, start asking yourself, how can I leverage tools that give me better access to information I need? And the more we have those conversations, sometimes that information is just a few clicks away. It's just not being provided or submitted as part of the official delivery. So have open dialogue, have the conversation, and yeah, let's make our jobs easier ultimately at the end of the day.
That's great. Great answer. Anybody else have anything to add on that one? Okay. We've got another one here. I'm going to direct this over to Taylor. Taylor, what are you finding is working with FDOT's implementation of the program, and what has not been working as well so far?
Okay, well, I think I mean, as far in terms of like what's not working, I don't think we've encountered really anything that is gonna kind of stop the show or stop us from moving down this path that we've started to go on. I think one of the biggest challenges is trying to get the majority of our industry, our consultants, our resident offices to see these benefits. I mean, because not everybody's like y'all. Like I've heard Tony say, y'all have been using rovers for the past 15, 20 years on projects. We never required that or asked for any data to be produced. That's just a tool that y'all decided to use because of all the benefits that you've seen in it. Not everyone's like that. A lot of folks still rely on printed out plan sets that they're taking into the field and flipping it over and writing notes on the back of it and using highlighters. And as that may work, like everybody's been saying, Andrew's been saying, I mean, this is kind of an industry move into more of a digital world. Everybody's moving to more model-centric plan design, and capturing digital data is becoming more important. So that's kind of our challenge, is getting everybody to see those benefits. What's working for us, and I think what will work moving forward, is just taking small steps. These pilot projects, the first phase is done. We're considering it to be a success. Sure, there were some challenges for some, but overall, I think it's going to benefit a lot of folks once they can see what all the capabilities.
Yeah, absolutely. We've had great participation amongst the pilot teams, and everybody's been very helpful and using the equipment and giving us feedback. So it's been a real great process through phase one. Look forward to continuing on. Okay, thanks, Taylor. One last question here. Andrew, direct this to you. What CDE platform is or are utilized to coordinate design and construction communication? CDE, I'm thinking, is maybe common data environment. So any cloud-based information being used to communicate between design and construction.
Yeah, I can make a comment of what we've seen kind of working with different agencies out there, and then I'll let Olivia and Taylor kind of chime in from an FDOT perspective. From one of the previous slides, I know that there were a few pilots going on involving Trimble, Synchro, as well as some other platforms. But what we're really finding is we have a massive shift in industry now, where there's a lot of different software vendors, kind of levying for their space in industry. I'm not sure if you're aware of the IFC, or Industry Foundation class, that's been kind of approved by AASHTO as the go-to kind of PDF of 3D modeling. You're seeing varying levels of support across industry. I think everyone's kind of begrudgingly going along with it, to kind of say in jest. Each of the software vendors wants you to kind of stay within their ecosystem. The vendors like Quadri, I know there's the iTwin on the Bentley side. They're really having these one-stop shops if you're in their ecosystem, but they're starting to talk to each other a little bit easier than they have in past years. But yeah, there's quite a different options out there, but I'll leave it to kind of Taylor or Olivia to talk through what FDOT is using in this case.
Sure, I can speak a little bit on it. I mean, that's part of this push. I mean, our CAD offices make changes, our design offices make changes, we make changes. We're trying to like bridge the gaps between especially design and construction. Right now we're using a Project Solve SharePoint as our collaboration site. So everything, all the design files, there's a kind of a brief list of things that were deliverables that come from design into construction. That's all housed in Project Solve. So each project has its own site, so you're able to see the project plans, all the project documents are uploaded there. So that's what we're using currently. I know there's we're looking into replacements for that allow for more of a like a workflow from design going into construction, and a way to keep a lot of the data, not necessarily just end in construction, and then we just turn in a PDF plan set, and that, all the data is done, after that, so we're looking into ways to try and have a more collaborative workspace for sure.
Fantastic. Okay, that's the questions we've got. So we're right near the top of the hour. So we're gonna go ahead and wrap this up. I want to again thank all of our speakers for joining us today. We hope you got something out of this webinar, and I hope everybody has a great day. Thanks for joining us.